Hello students. So what are salts? The moment when you used to hear this word salt, what is coming in your mind? Salt means what we know is sodium chloride. Yes, no students. But listen, salt is not a compound name. Salt is a family name. That means not only sodium chloride, like any other metallic component which is combines with a non-metal or a group of non-metal radical, we can get the salt. For example, magnesium chloride is a salt, potassium chloride is a salt, sodium bromide is a salt, and not only these halogen students, even the carbonates, bicarbonates, nitrates, all these category of compounds comes under this classification called as salts. So I hope you got the clarity about the introduction about salts. So how can we synthesize these salts? So in general, salts are found plenty in the nature, like mostly in the sea water. And what we know about sodium chloride, potassium chloride, calcium chloride, most of them are available in the sea water, as well as the remaining salts are available in the combined form on this earth crust. So the most common salt that we use in cooking is sodium chloride. That is called as common salt or table salt. So that's the reason why we used to call the normal salt as sodium chloride. Why? Because that is used in the cooking. So properties of the salts, like what are the properties of the salts? Most of the salts are solids with high melting and boiling points. That means these salts which are highly ionic in nature, their melting and boiling point is very high. So these opposite ions mostly combine in this crystal lattice. Perfect arrangement of all these ions makes the particular salts with having high melting and boiling points. For example, let us consider sodium chloride. The melting point of sodium chloride is almost around more than 1000 Kelvin. The melting point of H2O is 0 degrees Celsius. Boiling point is 100 degrees Celsius. The melting point of sodium chloride is more than 1000 Kelvin. So because they are opposite ions, they are made up of opposite ions which are perfectly arranged in a crystal lattice. So salts are usually soluble in water. However, salts like carbonates, oxides and sulfates are generally insoluble in water. Generally, salts are soluble in water. Like sodium chloride, can it dissolve in water? Yes, it will dissolve in water. But not all the salts are soluble. Not all the chlorides also. There are many exceptions. First of all, when it comes to the solubility, there are some factors which influence the solubility, students. For example, having the ionic character. Not just having the ionic character, and it should have hydration enthalpies also, and these hydration enthalpies makes the components to attract the water molecules, as well as atomic size, ionic size is also the reason why these particular salts can easily soluble in water, students. So all these factors influences the compounds. So not all the oxides are insoluble. Magnesium oxide in water, it forms magnesium hydroxide. Calcium oxide in water forms calcium hydroxide, forms new compounds. So next, salt solutions in water are good conductors of electricity, right? Salts are made up of opposite ions. When they dissolve in water, they release the opposite ions, and these opposite ions are the reason why salt solutions are good conductors of electricity. So next, preparations of the salts. So these salts are mainly prepared by the famous neutralization reaction. When an acid reacts with a base, it produces salt and water. So here zinc hydroxide is a base, H2SO4 is a sulfuric, it is an acid. When a base reacts with an acid, it produces a salt and water. The general neutralization reaction, acid plus base gives rise to salt and water. And how to write the products? Double displacement reaction. Zinc combines with sulfate to form zinc sulfate. It is a salt, sulfate, yes or no? And the remaining part is H2O. As well as when acids, when they combine with metals or metallic oxides or metallic carbonates, they produce the particular salts. Here in the given slide we have sulfuric acid. So what is the salt we got? Sulfate. If it is a nitric acid, what is the salt we can expect? Nitrate. If it is hydrochloric acid, what is the salt we can expect? Chloride. Depends upon the type of acid and depends upon the type of metal, we can expect the respective salt and the water. Understood, students? So Zn plus H2SO4, here we got metals react with acids to produce metallic salts and hydrogen gas. And when metallic oxides in presence of acid, they produce metallic oxides are basic in nature, yes or no? And it is an acid, so neutralization reaction. Carbonates in sulfuric acid produces the respective salt as well as water, and carbon dioxide is released in case of carbonates. So by the reaction of non-metallic oxides with bases, for example, non-metallic oxides. What are non-metallic oxides, students? Carbon dioxide, sulfur dioxide, nitrogen dioxide. What is the nature of non-metallic oxides? Non-metallic oxides are acidic in nature. So when they react with these metallic hydroxides are direct bases. So this reaction also neutralization reaction. Here also we can expect a carbonate as well as water. Calcium carbonate is also a salt, right? So next we have types of salts. So first, normal salt. So students, here mainly we have three types of salts: normal salt, acidic salt and basic salt. Normal salt means the salt which is obtained by the complete replacement of hydrogen ions. That means if you can check the formula of sodium chloride, do you find any hydrogens in the formula? No. Do you find any hydrogens in potassium sulfate, calcium carbonate, copper nitrate? No. That means these are the salts which are produced by the complete replacement of hydrogen. So that these salts, they do not contain any replaceable hydrogen ions. That is called as a normal salt or neutral salt. What is the definition? The salts which do not contain any replaceable H plus ions or OH minus ions also. That is called as normal salt. You can check the formulas. There are no H plus or OH minus ions. Then what is acidic salt? Simple. If a salt contains replaceable hydrogen ions, how it is formed? It is produced by the partial ionization of the particular acids. For example, sodium hydroxide reacts with sulfuric acid. Sulfuric acid is what type of acid? It is a dibasic acid. Yes, sir, students, it contains two hydrogen ions. If only one hydrogen is released, not two hydrogens, in case if only one hydrogen is released, then what is the compound we can expect? Sodium hydrogen sulfate and the respective water molecule. And this sodium hydrogen sulfide, in presence of water, it can also release one more H plus ion or not? Now ultimately we'll get neutral salt, but this step students, this is called as acidic salt. This is acidic salts. Why? Because you can check under the ionization, under the decomposition of this particular compound, we are getting a respective H plus ion. You can check, check in the reaction this H plus ion. So once if this H plus ion also released, then can we get, still is it the acidic salt? No, then we can get a neutral salt which is sodium sulfate. There are no hydrogen ions. If there are hydrogen ions, that particular salt is called as acidic salt. So sodium hydrogen sulfate. Look at the formula: NaHSO4, potassium hydrogen carbonate, KHCO3. So when these salts are obtained, these salts are produced during the partial ionization of the respective acids, right? Next, basic salts, the same concept, partial ionization of the bases. So we can expect a replaceable OH minus ions in this particular formula: zinc hydroxychloride, ZnOHCl, and copper hydroxychloride, CuOHCl, or magnesium hydroxychloride, MgOHCl. So what is the common thing if in all these basic salts? The common thing is OH. Yes or no? It will be released as OH minus ions and OH minus ions, which is a basic nature. It is a salt, but still contains the replaceable OH minus ions. That's why these are called as basic salts. Next, naming of the salts. How to name the salts? These salts you already know. These salts are obtained from different acids and different types of bases. So definitely the names are also derived from that particular acidic and basic names. Salts which are obtained from the sulfuric acid. What is sulfuric acid formula? H2SO4. So what is anion which is present in the sulfuric acid? Sulfuric acid releases H plus ions. Yes, sir. What is the remaining part? Sulfate, SO4 minus 2. And the respective salt is called as sulfates only. If this sulfuric acid reacts with sodium sulfate, magnesium sulfate, calcium sulfate, and so on. That's it. Understood? So all the salts which are obtained from sulfuric acid are called as sulfate or sulfate family. Sodium sulfate, copper sulfate, and the formulas depends upon the valencies of the particular metal. And the salts which are obtained from hydrochloric acid, you answer what is the name of their family? Chlorides. Sodium chloride, potassium chloride, magnesium chloride, all chlorides only. Understood? So the names are coming from the respective acid as well as a metal present in the base. So next, students, we have salts obtained from nitric acid are called as nitrate, phosphoric acid are called as phosphates, carbonic acids are called as carbonates. Look at the examples: calcium nitrate coming from nitric acid, lead nitrate, nitric acid, and calcium carbonate, magnesium carbonate. From phosphoric acid, what is the radical present in phosphoric acid? H3PO4. PO4 minus 3, phosphate, yes or no? So we have calcium phosphate and potassium phosphate. So next we have hydrated salts and water of crystallization. Hydrated salts means, students, the salts which contains the water molecules, they are called as hydrated. When you heat these hydrated salts, the water molecules will be gone and the salt becomes anhydrous or anhydrated salts. Understood? So now what is this water of crystallization? These salt molecules contains the forces of attractions, and because of these force of attractions they can attract the respective number of water molecules, and these water molecules are fixed, depends upon the type of salt. So all the salts are not hydrated. Sodium chloride, students, does it have any water molecules? No, it depends upon the arrangement of the ions and depends upon the force of attraction that particular molecule can exhibit. So here, and what is water of crystallization? This particular number, the fixed number of water molecules which are attached for a formula unit of a salt is called as water of crystallization. Here look at the formula, CuSO4.5H2O, which is CuSO4.5H2O. This is called as blue vitriol, students. And how many water molecules are arranged for one molecule of copper sulfate? 5. What is its water of crystallization? 5. That's it. Copper sulfate, and what 5 means pentahydrate. Hydrate means number of water molecules. Green vitriol, FeSO4. This is how many? 7. Heptahydrate. 7 water molecules. So what is the water of crystallization? 7, right? Heptahydrate. White vitriol, same, zinc sulfate and 7H2O. This dot 7H2O means 7 water molecules are surrounding one molecule of salt. It doesn't mean it's a solution, it's a solid powder only, students. But these molecules are attached at the molecular level for the one molecule. Each molecule, one molecule means don't think only one molecule of salt is getting like that. No, all the molecules of that particular salt attached by the fixed number of water molecules. White vitriol, 7. Glauber salt, which is sodium sulfate dot 10H2O. Here the water of crystallization is 10. And washing soda, the most famous example, washing soda, sodium carbonate decahydrate, students, which is 10H2O again. And Epsom salt, this is also most famous, magnesium sulfate heptahydrate. And this number of fixed number of water molecules which are attached to the formula unit of a salt is called as water of crystallization. Uses of salts, we have like first common salt, that's the first salt, right? Majority of the seawater contains this sodium chloride only. So what is the use of sodium chloride? Mostly used in cooking for us, right? Use means what for us? It is used in large amount of table salt. Table salt means for our cooking purpose, and it is used for the preservation of food and pickling. Pickling means you already know. Pickles, for the preparation of pickles, and as well as for the preservatives also. Even the ancient Egyptians also, for in the process of mummifying the bodies, mummification, they use this sodium chloride for preserving. So it is used to preserve raw hides, means leather, leathers also, materials also we can preserve using this sodium chloride. Otherwise they will undergo decomposition. It is used in the manufacturing of chemicals such as chlorine and caustic soda. Sodium chloride formula NaCl. So for the preparation of chlorine also we can synthesize from sodium chloride. What is the use of chlorine? It is used as a disinfectant as well as for the preparation of other useful components also. And caustic soda, which is sodium hydroxide, which is a strong base. It has many uses even in the organic synthesis reactions also. Baking soda, this is also famous compound in the market. Baking soda, NaHCO3, sodium hydrogen carbonate. It is used for making baking powder, like for cooking purpose, students. When we add this powder, we can get that fluffy kind of bread. Yes or no? Why? Because these hydrogens are escaped and that creating some small holes in the bread or cake. So that's why baking powder. As well as it is used for the preparation of antacid tablets for controlling acidity of the stomach. Antacid tablets means if you feel indigestion. In that case of tablets also this particular chemical is being used, sodium hydrogen carbonate or baking soda. Washing soda, Na2CO3.NH2O. It is used by washermen to wash the clothes. It is used in the manufacturing of glass and caustic soda, which is NaOH, and it is used in the fire extinguishers also. In order to stop the fire also, one of the key reagent is sodium carbonate. It is used in the manufacture of detergents, which is for ultimately this is used for washing purpose. And chili saltpeter, which is sodium nitrate, students. Most of these nitrates are used as a fertilizers or explosives. So it is used in the manufacturing of nitric acid, gunpowder and fireworks. It is used as a fertilizer like niter, potassium nitrate. It is also used in the manufacturing of gunpowder, fireworks and nitric acid. Both have almost same uses. Sodium nitrate is called as chili saltpeter, and KNO3, potassium nitrate, is called as Indian saltpeter or Bengal saltpeter. Almost both have identical uses, like for the preparation of nitric acid or a fertilizer, or even a gunpowder for explosive fireworks preparation. All these have these identical uses. Smelling salt, ammonium bicarbonate is called as smelling salt. If you are feeling with cold, suffering from cold, so because of the effect of the smell, we can get the instant relief. So that's what it does. It provides a relief from the common cold. So it's very smelly salt. And Epsom salt, magnesium sulfate .7H2, it is also used as a fertilizer. It is used as a laxative by patients suffering from the constipation, like same indigestion. So the people who are suffering from indigestion contains, the tablets also contains magnesium sulfate also. Not only magnesium sulfate heptahydrate, students. Does it mean, is it a liquid solution? No, it's a powder, but 7 water molecules are surrounding 1 magnesium sulfate molecule. So it is also used as laxative, means a tablet which fights for constipation, indigestion problems. So green vitriol, it is used in making blue or black inks. Like how it can make blue means, but you already know that when you mix different colors, it forms a new color, so in that way it is used in making mostly dyeing purpose, blue or black inks. And blue vitriol, this is also most important chemical. Copper sulfate pentahydrate is blue vitriol, students. It is bluish in color. So it is used as a fungicide in the agriculture industry as a fungicide, and it is used in dyeing and printing industry also. It is used in electroplating of copper metal. So copper sulfate is mainly used as an electrolyte, like Cu+, Cu+2 and SO4-2 ions used. This solution is used as electrolyte in electrolysis under electroplating of copper metal. Why? Because copper is a corrosive metal. So plaster of Paris, which is calcium sulfate, half H2O, hemihydrate. What is half H2O? Does it exist only half H2O? No, it means for 2 calcium sulfate molecules, we have 1 molecule of water. For 1 molecule, how much percentage? Half. That's what it is. So it is used for making the statues. It is used for settling of the broken bones. This is also most famous component, sir. No. So like statues, idols, or roof materials made up of this plaster of Paris. When you add some water to this plaster of Paris, it becomes a very solid hard substance called as gypsum, CaSO4.2H2O. So that's what the making process. Potash alum, which is potassium sulfate, aluminum sulfate, and .24H2O. It helps in the rapid settling of suspended impurities in water. It is used for the purification of water, like dirt water. When you add this alum, these dirt particles are directly stick to this alum and becomes a precipitate. That means it's insoluble solid. If it is an insoluble solid, what happens, students? Undergoes sedimentation. All the particles will settle down. That clears the dirt particles in the water, and by careful decantation, you can remove the fresh water. So potash alum is mainly used for water purification techniques. That's all about the salts. A salt is not a compound name, it's a family name. There are many types of salts are there, students, but it depends on based on the combination, preparations, properties, physical properties, as well as chemical properties and uses. And this chapter is completed. Thank you, students.